Okay, hello guys, Adibala here, and I'm going to start in just a few seconds. Let more people to join this meeting. And today I'm going to show you how to create 3D video game in less than 1 hour using SceneMax3D technology. SceneMax is a computer programming language which is specific for children and for educational purposes, and we're going to use it today, and that's it. So in a minute we're going to start this session. Let others chance to join from all over the world. Okay, so hi again, Adibada here, and as I said, I'm going to show you how to use SceneMax3D programming language to build real nice, simple 3D video games. We're going to start from scratch, from nothing on the screen, and until the last step where we have a fully functional working game ready to be deployed to itch or Steam or whatever online store. So first thing first, I want to introduce you. This is the SceneMax development environment. As you can see here, this is version 1.1, and it's very simple. Okay, the main thing here is the text editor. We can type our code here. And on the left side, we have a few buttons. The most important one is this one, the play button, the run program button. So we type our code here and we run by clicking this button. So first thing first, we have to complete full 3D game in 1 hour. So I'm going to do it fast enough. Feel free to ask anything you like during this session, and we are going to start. So the first thing I'm going to do for creating my 3D game is to create a new project or create a new folder for this game. So this is I'm going to click on this button, the create folder button, and give it a name, my game. Click enter, and you can see there is a new folder for my game, and it has 2 files under it. First is main, and the second one is tests. Okay, so main and tests are files, and I can use or not use them. Most of the time I'm going to use the main file, and just make sure to click on this main file and just then click here your code. So first thing, I'm going to tell you which game I'm going to design today. So I'm going to create a shooter game, okay, a 3D shooter game. It's very simple. I'm going to do like, I have a kind of spaceship above the water, flying above the water, and some kind of green hawk throwing fireballs at it. And I want to avoid the fireballs, and meanwhile we have some kind of phoenix, like phoenix bird, which is throwing coins at us, and we need to collect the coins. Okay, so we need to collect coins and gain points and avoid the fireballs. If fireballs is collides with our spaceship, then we lose life. We have, let's say, 3 life, and until we reach 0, then game over. So how do I do that? I think I'm going to put the main characters on the screen. So I have a car. Car is a buggy. So new object, type of buggy, and we have an enemy. Enemy is a Sinbad. Sinbad is also a 3D model which exists in our resources folder. And the last one is our phoenix. So let's call it bird. Bird is a phoenix. So three 3D models. And let's run our game. Remember, clicking on this play button, and let's see what happens. Let's see what happens. Nothing happens. Oh, yeah. Okay, so here we go. We have our game started, and our 3 main characters are on the screen, waiting up for us to do something nice with them. So this is our enemy, the green hawk, which throws things at us. This is the phoenix, throwing coins, which we need to collect. And this is us, some kind of buggy, spaceship, or I don't know, something like that. That's not important. By the way, you can download whatever 3D models you like from, for example, Sketchfab, as long as you download it as a GLTF files zipped. Okay, I will show you in later on. So, okay, so we have our 3 characters on the screen. Next thing, I'm going to put our characters in their position. So I'm going to push. I'm going to put the enemy 30 meters back in the scene. So position equals 0, comma 0, comma minus 30 meters. Okay, so position is X, Y, and Z axis, and I'm going just to push it back on the Z axis 30 meters. Same thing, I'm going to put my bird 15 meters back in the scene, so minus 15 meters on a Z axis. Let's run this program now. And let's see. Yeah, so great. Now our objects are positioned in the desired position. Next thing, I'm going to move my car, let's say, down 2 meters in 1 second, to put it a little bit lower on the screen. So let's just run it and see what happens. Yeah, great. So as you can see, now it's in the correct position. Okay, so let's start with some kind of working game. Next thing, I'm going to put skybox. Skybox is like the background for the scene. So skybox. So I have all kind of options. I'm going to put a lagoon. So now, having this line, I expect to see, and here we go. We have now a background of a nice lagoon, mountains, etc. Next thing, I'm going to put some water effect to make the scene to look a little bit more realistic. So water.show, and let's see what happens now. Hopefully, yes. Okay, so now you can see we have our background and we have water above the background. Nice water effect and the reflection of our models on that model. That reflection of our characters on the water. Good, we have a game. Okay. So let me just make the font a little bit smaller. Now, what else? Okay, so next thing, I want my enemy to move from right to left, okay, from side to side, throwing fireballs at me. Okay. So I'm going to write function. Let's do some comment here to have clear help us understand the structure of our code. I'm going to write a function, call it move enemy, and put it in a do and do block. What I'm going to do in this function is I'm going to move my enemy, that move left, let's say 10 meters in 2 seconds, pretty fast, and then I'm going to move to the right 20 meters, let's do it in 4 seconds, and then left again, back to the center in 2 seconds. Right, so now I have this nice function, and if I'm counting all this amount of seconds which takes my enemy to move from side to side, 2 plus 4 plus 2, it's 8 seconds, so it's safe to run this move enemy function, yeah, every, let's say, 10 seconds. So if I'm running this function every 10 seconds, I expect my enemy to pause in the middle for 2 seconds and then do its movement, which takes 8 seconds. So let's see how it works. Clicking on this play button, and now I expect my enemy to move from side to side. Let's see it happens. Yeah, as you can see, the green hawk here is moving from side to side, waiting 2 seconds, and again, from side to side. Right, great, nice. We have a game. Okay, so next thing I would like to do is throw fireballs at me, the buggy, the car. Okay, so let's write another function. Let's go fire, so enemy fire, me fire, and again function. Function, let's call it fire equals to entity, and we are going to actually do the fire thing. Okay, so let's just make some space here, click a few spaces here, and firing, I would like to we're talking about fireballs, right? So let's do it like that. S1 is a sphere, having material equals alpha. We put some kind of material sphere, and position equals, let's say, enemy. We want to start from the enemy position. And what else? Okay, and we want our sphere to move to the car, and when it reaches the car, I want it to move extra 10 meters, so car plus 10. Let's do it in 2 seconds. Of course, this is a very naive algorithm, but you can change it and make it work with random numbers, etc. But for now, you know what? Okay, so let's do it in 1 second plus R&D of 2 seconds. Okay, so it will move in a random speed, make it more interesting, right? So great, we have a fire function, and let's run this fire function every, let's say, 3 seconds. So every 3 seconds I expect my enemy to throw a fireball at me at a random speed. Great. But a few things are important, which I forgot. We need to run the move enemy function every 10 seconds, but let's do it asynchronous. Okay, I don't want it to stop the program. And also here, asynchronous, I don't want this interval to stop the program. So let's run and see if we have a fireball thrown at us. Let's see, yeah. It is working, yes. We can see a fireball which is thrown at us every about 3 seconds, and it is flying at us at a random speed, exactly as expected. Great, great, great. Okay, so next thing I would like to do is get input from the user and move. Okay, I want to move my car as a response for input from the user. So what I'm going to do is get input. So I'm going to use the arrows for the movements, left, right, and forward, backward. So I'm going to do this. When key left is pressed, do undo, and I'm going to copy this. No, I'm going to move. No, I'm going to car move left 1 meter in 0.1 seconds. Great. Now I'm going to copy this code and make the same for all the other arrows. So I'm going to make it right and move right. I'm going to make it up, move forward, and down arrow, move backward. So I'm not sure about the forward and backward thing. Let's see if it works as expected. If not, I'm going to swap between them. So I just wrote it in plain English actually. When key something is pressed, do something with the car. In my case, it's move left, right, forward, and backward. Easy. And in all cases, it's 1 meter in 0.1 seconds. Great. Let's see how it works. And hopefully it will work exactly as expected. Yeah. Okay. See? Now I'm clicking on the arrow keys and everything is working as expected, except two things. I see now that my car is pointing backwards, so I'm going to rotate it 180 degrees. And the second thing is when I click on the buttons, on the up and down buttons, it moves backwards and forward in the opposite direction. So I'm going to first swap between backward and forward. Okay, now it will work. Okay, and as I said, I'm going to rotate my car here. Having rotate, I'm going to rotate my car 180 degrees around the y-axis. Okay, so this is how I rotate my model. Again, this is the X, Y, and Z axis. So here I'm telling my car to initially rotate it in 180 degrees. Okay, so let's run it again and see that it looks fine. Come on. Great. So now it's working as expected. I'm clicking on the keys and it's moved backward and forward, etc. And everything looks just fine. Now I'm going to print the my score and the amount of life that I have for my buggy and put it on the screen. So first thing, I'm going to define my score variable, which equals 0, and my life variable, which equals 3. Next thing, I'm going to create another function. I'll put it here as a print score and Okay, so the function is, I'm going to call it update screen and equals do and do, and I'm going to update the screen. So I'm going to print score.print score plus score in a position of 0, 0, 0, and the same for life. So life.print life, and I'm going to put the life text on the right corner of the screen, so it's going to be 600. Yeah, so the screen is 800 points by 600 points, so I'm going to put it 600 points on the x-axis, and of course I'm going to initially run the function. So run update screen, and now I expect to see my score in life printed on the screen. Great. Well, the font is too big, so I'm going to make it a little bit smaller and also avoid the the floating point. So let's make the size the size of it equals 1, again equals 1, and let's apply a round function on the life and score to avoid the floating point. So let's see it again. Okay, so now it looks pretty good. We have a score and we have life 0 and 3, and we have a green or I don't know what to call it, our enemy throwing fireballs at us, and we have this phoenix here, which does nothing, but it will do in a second. So let's now like make the phoenix to move as well. Okay, so let's create another function, move bird function. Move bird equals do and do, right? And what we are going to do here is actually the same as moving our enemy, maybe a little bit different. So I'm just going to change, instead of enemy, I'm going to move the bird. And I'm going to do it in the opposite direction. So if the enemy is moving left, right, and left, I'm going to change it and make it right, left, and right. So now, yes. And last thing, I'm going to make it move a little bit longer direction and distance. So, and let's do 24 meters and again 12 meters to the right. And let's do it a little bit faster. So let's say 1.5 seconds. Let's say 4 seconds and 2 seconds. Okay. So we have a moving bird here, and I'm going to run this move bird function every, let's say, 7 seconds. Again, asynchronous, so it will not stop the rest of the program from running. Okay, so let's run it again. And now we have also our bird moving. So everything now is moving and very responsive. We have a game, guys, okay? Great. Okay, next thing I want to do is apply some animation, flying animation on this Phoenix. By the way, I have downloaded this Phoenix bird from sketch.com. You can do the same and just download any model you like, as long as you download it as a GLTF file, import it to the system. Okay, so as I said, I want to apply the fly animation, so now let's do it. After the positioning, I'm going to do bird.fly in a loop. I want it to fly again and again and again, and of course asynchronous, not to stop the rest of the program from running. Okay, so let's look at it and see. And as you can see, now we have a flying phoenix. Excellent. Great. Our shooter game, arcade game is almost ready. Now, kidding. We have still plenty of work to do. Okay, so next thing I'm going to throw coins from the bird down. Oh, I think I forgot to do something. Yeah, really important thing. When firing balls here, fireballs, so moving, after shooting the fireball, I need to hide it, so I will not have a memory leak. Okay, I want to keep my game performance well, so I'm going to simply hide the fireball when it when it reaches that position. So now it looks fine. And next thing I would like to create a new function here for the bird, for the phoenix, to throw coins, so I can collect it. Okay, so let's call it throw coins, and I'm going to create a new function, call it just coins equals do and do. And what we're going to do here is create a coin. So how do I create a coin? I'm going to declare it first. So C1 is I think we have, hopefully we have a coin type. So C1 is a coin having position equals bird. Yes, we want the initial position to be the same as the bird position. And I'm going to, okay, so now I want to throw it in a little bit fancy way. So I don't want just to throw it linearly. I want to make it do some kind of throws, like jump the coin and just then throw it. So I'm going to run a function called jump, send it my C1 object, and do it, no, I don't want it to be asynchronous. When the jump function finishes its work, then and just then I'm going to move the coin down to the water. So C1 dot move, let's say 2.5 meters in 1 second. And then I'm going to wait 5 seconds for the buggy for the car to collect it. No more than 5 seconds, and then I'm going to hide it so one can do anything with it and we don't have a memory leak. So now I'm going to run this coins function every, let's say, 5 seconds. 5 seconds? No, every 3 seconds. It's faster, and of course asynchronous, so it will keep the rest of the program from running. And one thing, this jump function doesn't exist until I'm going to add it to my program. So we have a pre-made jump function algorithm. It's very simple, very small, but still I don't want to write it. I can find it here in the code snippets. Let's take a look at it. See, we have a jump macro, yes, which adds this function jump, this jump function, and do some things with the object, with the argument. So instead of, I can just copy this jump function and put it in my code, or I can add this code snippet. So I'm going to show you how I'm adding a code snippet. So I'm going to the last row of this program and just type the name of the macro, and now I know that I have a jump function. I've added the jump function. So let's see if our coins function, let's call it throw coins, okay? Throw coins. So let's see if our throw coins function is working as expected, and we will fine tune it if needed. Okay, so we have some kind of trouble, and we're in the c1.move, and let's see what happens. c1.move. Oh, okay. We cannot just simply move. We want to move down 2.5 meters in 1 second. So let's run again. See what happens. Great. So it looks like it is working. The coin doesn't look very good because we need to rotate it a little bit, but it's working. The Phoenix is throwing coins at us, and it looks fine. So what I'm going to do here is rotate a little bit our coin. Okay, so position equals bird, and initial rotations equals 0, no, you know what, 90 degrees on the x-axis, 0 on the y, and 0 on the z-axis. And in addition, I would like to turn my coin, let's say 360 degrees in 1 second, and I want it to turn the coin, let's say forward 360 degrees in 1 second, and I want it to repeatedly do that. So I'm going to create a loop. Okay, so do, let's say, 100 times and do. So now we have a loop of 100 times. We're going to turn our forward. Let's see if it works. And I'm going to do it asynchronous, so it will not stop the jumping and moving. Let's try it out and see if it works. Hopefully it will do. Yeah, yes, okay. So now it looks much better. We have the Phoenix throwing coins, and we have the green hawks throwing fireballs, and we just need to collect them. Okay, just need to collect the coins. So now I'm going to introduce you collision detection. Okay, so the first thing I want to do is to handle the situation, the event where our car, or yeah, when our car hits the fireball. Okay, so in the event fireball hitting our car, I want to reduce the life until I reach 0, and then the game is over. So how do I do the collision detection? It's really easy. I'm typing this thing: when collides with car, do and do. So really easy. I'm going now to do some things, and the first thing I'm going to do is I'm going to reduce the life. So life equals life minus 1. Second, I want to hide the fireball. And third, I'm going to update the screen captions. Okay, so, and how did we call the update screen function? We call it update screen. Okay, so we are going to run the update screen function. So now I expect every time a fireball hits me that the life will reduce 1 point, and then we will see what we will do with it. So run again, and let's see what happens. Okay, so here you see the fireballs are hitting me, and the life is reducing 1 point every time. Here we have -1, -2. Of course, it doesn't make sense. We want to reach 0 and then run the game over function. So great, but the collision detection is working as expected. Great. Next thing I want to, we will get back to the collision detection in a minute. Now I want to do the same collision detection with the coin. And I'm going to type when C1 collides with car, of course, do and do. And what I'm going to do here is, of course, add some score. So score equals score plus, let's say, point, and of course I'm going to update my screen, and let's see how it works. Every time I'm colliding with, right, you see now, okay, now I have some kind, you see the score is running very fast because the collision never ends. Okay, I have collision all the time because I didn't do anything with my coin. So when I hit the coin, I can hide. I need to either hide my coin or do something with it, but I don't want the coin to stay in the same position, because then I will have continuous collision with the car. So how do I do that? I think I'm going to run the jump function on my coin, synchronous, while moving my coin backward to the same position of the enemy, let's say plus 10 meters. Let's do it in 1 second. So it will do some kind of throwing the coin away from me towards the enemy every time I hit the coin. So let's try it out and see what happens. Okay, let's just catch this coin. Great, you see? The coin was thrown away to the enemy. Now the points are rising in an expected, in a desired way. So now you see that in just about 30 minutes from the point we started, I have a working game, okay, with collision detection, with models, everything. Now again, I'm just going to, so the skeleton of the game is working. Now I'm going to just do some kind of fine-tuning and effects, etc. to make it better, but it's almost done. Okay. So 30 minutes, we have about 15 minutes to finish our game. So let's get back to the collision with the fireball. So we updated the screen and then etc. And now we're going to check and I'm going to check if life equals 0, then do something. I'm going to run the game over function, which I didn't write it yet, but I'm going to write it now. So I'm going to put my game over function here. So function game over equals do and do. And what I'm going to do in this game over, I'm going to print game over. Okay, so let's open a new channel, a new printing channel, and print game over. Like this, game over, plus new line, plus press P to start. Okay, so now we have nice game over. Also, this is a good place to change the state or the status of the game. Let's use another variable. Let's call it game status equals 1. Okay. So game status equals 1 means I'm going to put my game in game over status. Let's quickly define this game status variable. Let's put it 0. 0 means the game is running or beginning. Okay, and get back to the game over. So we printed here the game over text, but I also need at that point check when the user is pressing the P. I want to start the game again. So when key P is pressed, do and do. And what I want to do now is run a function. I call it start over. I didn't write it yet. I'm going to do it right now. So let's start it. type this function. So function start over equals do and do, and I'm going to reset my game. So game status equals 0. 0 means running. Life equals 3. Score equals 0. And that's it, I think. And I'm going to, of course, turn off the game over caption. So I'm just going to use the game channel, okay, the game printing channel, and just print an empty string. And since I reset the life and the score variables, I would like to update my screen. So run update screen. Great. Just to be on the safe side, I would like to add when key P is pressed once. I don't want to be a continuous clicking on the keyboard, just one click. And I'm going to be on the safe side and check that the game status variable is actually equals to 1 before I'm running the start over function. So if game status equals 1, then and only then do the start over thing. Okay, so now we have a real nice game over and start over functions. I really hope it will work as expected. So let's try it out. But now, since we have a game status variable, let's say that we will not fire fireballs if the game is in a game over status. Okay, so I'm going to ask a question: if game status equals 1, then do and do means that if the game is over, then return. Okay, I would like to simply return. I don't want my enemy to throw fireballs at me as long as the game is in a game over status. Okay, what else? I think that we're good to. So let's say I think 40. Okay, we have some kind of exception here. Nothing special. I'm just going to save my work, close the development environment, and reopen it. There is some kind of memory leak in the development environment. Nothing really interesting. Just run it again, and in a few seconds it will show again. We can continue our work. So here we're back, and I'm going to make the fonts a little bit louder. How do you make the fonts louder? Just click on the Control plus. That means Control plus, Control minus, you make it smaller. Control plus, you make it larger. So when you teach your kids, and this is an educational programming language, right? It meant to be used for educating, for creating games. Okay, so as I said, we have now our fireballs throwing it out at us. The game status is not in a game over status. Okay, so let's run and see if it's working as expected. Okay. Great, so now I'm going to collect some coins, I'm sorry, and here we have score, and we need to avoid the fireballs, but fireballs are reaching us, and let's see if what happens when we reach 0 life. Okay, so we reached 0 life, and we have a game over, and press P to start. Nice. We can move it a little bit to the right, so it will be in the center of the screen, but generally it looks really good. And you see now that the game status is 1. The green hawk here, our enemy, doesn't throw anything at us because of the if statement that we put in the fire. Now let's click on the P key and see that we are, yeah, okay, so here we go, and we run again, and nice. Okay, great. Now let's do some fine tuning, and the first thing I'm going to do is add a little bit of ambient music. So when the game starts, I would like to use my audio system somewhere, let's say here, audio, and play some nice action music. I'm choosing to run the dance track. Let's see how it works. Yeah, okay. So hopefully, I hope you can hear the music, and we have a dancing, some kind of action dancing music to make it a little bit nicer. Great. Second thing I would like to do is now we have a fully working game, right? Now I'm just going to put a little bit of effects and make it a little bit, you know, to look a little bit better. So what I'm going to do now, I would like to, let's say, I would like to add some effects when the fireball is collides with a car. So what I'm going to do is not just reducing the life. I would like to also okay, to shake the world. So I'm going to write a function, shake world. Okay, and let's do it. Let's run it asynchronous, and I put it here. Let's call it boom. So function shake world equals do and do. And what I'm going to do now is I'm going to move my car very fast, backwards and forwards and backward, forward and backward, to make the illusion of the world is shaking. Okay, so let's do it, let's say 3 times, and do of course, and our car dot move forward, let's say 1 meter in very fast, 0.1 seconds, and let's move it backward, and 1 meter in 0.1 second, and of course we're doing it 3 times. And shake world, this is the name of our function, and we are running shake world. So, and in addition, I would like to also car dot turn, let's say left full 360 degrees in 1 second. Let's do it asynchronous, of course, and I would like to also run some explosion effects. So effects dot explode dot show, having a position equals, let's put it in the car dot x, car dot y, comma, car dot z. So in the same position, car, yeah. So we have an explosion in the same position of the car. We have the car turning 360 degrees. This also should be asynchronous. And we have a shaking of the world. And what else? What else? Yeah. Also, I would like to use my audio system and play explode sound. I'm not sure if it's explode or explosion. Let's run and see if it works. So, we have a problem here. Explode, expecting, blah 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 blah. 100. Okay, so effects. Maybe effects. What again? What is the problem again? Oh, okay, so we don't have explode. We have explosion. So effects explosion show. Okay, so no explode, explosion. Let's run again. We have a compiler on our side which checks everything that we do. So, okay, so we have music. Okay, now you can see that we have the rotation, the explosion. Boom. Okay, great. And let's P again. And okay, so the car is moving forward and backward, but we don't see that the world is shaking. Okay, so in order to see the world shaking, I'm going to simply I'm going to have my camera attached to my car. So it's some kind of it's some kind of let's have our camera attached to the car. So right after positioning our car 2 meters down, I'm going to make the camera system camera dot attach. I'm going to attach it to my car, having a position of the camera. Let's put it 0 on the x-axis, 3 meters above the car, and minus 15 meters on the x-axis. So I'm going to look at it from this position. We can change it, of course. So let's see now what happens when we attach a camera to our car. Obviously, the scene will look a little bit different. Okay, so now it looks a little bit more first-person shooter, and I'm collecting the coins, and I need to avoid everything. Boom. Okay. By the way, I didn't heard the explosion the explosion sound. So I guess I made a little bit a small mistake here, and I'm going to just change the explode to explode. So now I think that it will work. Let's try it again. I expect to hear some kind of boom or something. Let's see. Still, I don't hear anything, so I'm going to guess again. This is one or something. Hopefully now we will hear a boom. Still no. So maybe explode one. Explode one. If not, I'm just going to look at my assets and see what's the exact name of this sound effect. Oh, okay. So it's explode now. See, now we have our world shaking and everything works as expected. What else? Yeah, I want. Great. Now we have an action game, and I want to add a sound when collecting the coin. I want to add a sound. I want to add a nice sound when collecting the coins. Let's see, where is it? The coins collecting. C1, yeah, here it is. When C1 collides with blah, I want to add system. I want it to. I think coin 2 sound effect, and I'm going to use it when collecting the coin. Okay, let's try it out. I think it's called coin 2. So let's see what happens when we collect a coin. Okay, so when I collect a coin, well, great, so now, great. I think the car is moving a little bit slow, so I'm going to make it a little bit faster. So when moving my car, I will make it move a little bit faster, especially to the right and left. So I will make it 0.05 seconds and 0.05 seconds to the right. Now I expect it to move a little bit faster. Let's try it out. Yeah, I think, yeah, definitely runs faster now. Great. So guys, so here we go. I just demonstrated how I'm creating a fully functioning game, 3D game, in less than an hour. It took me about 50 minutes, and I didn't do it the fastest. I could do it faster because I explained things while demonstrating this game. So as you can see, it's really easy to create games with SceneMax. The last thing I would like to show you is how to create an executable. Okay, so you can upload your game to itch or Steam or whatever online store there is. So to create your executable game, you just need to click on this package button here, and in just a few minutes, a few seconds, we will have working executable ready to be uploaded to whatever you want, whatever online store you want. Okay, so let's just wait a few seconds and have this miracle happening. And while we're waiting for this packaging to finish, I would like to also tell you that we have here the record MP4 button. So you can record a clip, a video clip of your game easily by clicking on this recording button. So this packaging operation takes from about 5 seconds to 50 seconds, depending on your hard drive and how the amount of memory that you have available, and the strongest computer you have, the fastest it will. But anyway, it's real fast, and it will finish its work in a few seconds, and I'm going to show you how I'm running my executable. By the way, I didn't show, and I would like to show you that we can easily make this game work in a full screen mode. Okay, and just a minute. Okay, so now when it finishes its work, it will tell us that we have a ready to use executable in a few seconds. In a few seconds. Now, yes. Okay, here we have this message telling us that everything is okay, and yes, we would like to see the executable. And here we go. Here we have our executable, and you need to upload it to, again, whatever store there is up there. I'm just going to double click and show you that it's working. And this is an independent executable. Okay, you don't need the development environment anymore. Okay, here we go. Nice. Now, as I said, I would like to show you that we can run this game in a full screen mode. So it's easy. Typing screen.mode full. That's it. I'm going to run it in a full screen mode now. And yeah, okay. So now we have a real nice game in a full screen mode. So that's it, guys. My demonstration has ended in exactly 1 hour. I showed you how to fully functioning 3D game and also explained a few things. Please download this development environment and this language from SceneMax3D.com, and email me anything you would like to ask about commands, about how to do stuff. Physics, I didn't touch sprite animation, etc. It was beyond of the scope of this really limited game, this really simple game. You understand it, you got the point, and that's it. I hope you enjoyed this session, and I'm really can't wait for showing more cool stuff. Bye bye.